Not the x, the y-axis. So reflected over the y-axis, right? That's one movement. Did this stuffed animal change at all when we reflected? Did he stretch? Did he grow? No, he stayed the same, right? So when we move from 2 down to 3, what do we have to do? Reflected over the x-axis. Did this stuffed animal change at all? No. Alright, moving on. Let's get a non-example. So a non-example would be where you do something and then the shape changes, right? Right? Right, Akeem? Right? So why is this a non-example?
Why is that not?
Yes, why is this a non-example of what an isometry is?
Because that's not a reflection.
It's not a reflection?
And see, they're not even the same size.
That's it. They're not the same size. So the key thing here is that both shapes have to be congruent. We can clearly tell that these two shapes are not congruent, right? Got it?
Yeah.
Moving on? No? 2 seconds.
You don't know what you're talking about. Okay, can you go over it again for Alicia? Because she's not with us.
I am. I did
Alright. Moving on. You don't have to get it from a neighbor. Alright, so on the back of your foldables. If not, you need to write this down on a sheet of paper, and I highly suggest, hint, that you transfer it over to your foldable. That might actually go into the grade. Just as a hint. Actually go into the grade. Yeah. Alright, so on the back, can I see yours? Really quick, Miles. So if you take your foldable, you see it? If you flip it around, this is the back. On the back of your foldable at the top.
So you mean this?
Yes, the back.
Yep, I did. I thought that stuff would be
Alright. I'm coming around with mini graphs.
I'm going to
If you have extras, just leave them on the table. I'll pick them up afterwards. I think I shorted y'all one. There you go. Alright, so. Alright, so remember on the other side, I was telling you that isometries, sometimes you'll have two that you can combine together. And today, that is what we're learning how to do. So, first things first, I'm the realist, but after that, alright, you have to know how to read these, and you have to know what in the world they're asking you to do. So, with these, they're written out just like everything else that we've written out. So we've learned how to write translations, how to write out reflections. Here, they give us a rule, but this one looks a little different. What's different about this one?
It's all in the same parentheses.
Hmm?
It's all like in the same parentheses.
It's all in the same parentheses, okay. Is there anything else up here that is like, it just looks a little different? It's not what you're used to seeing? Yes? Okay.
The degree sign. It
Doesn't have a degree sign, which gives us a hint that we're not doing rotations. Okay. So what I want you to see is what we're used to seeing is something like this, right? You're used to having one rule, translate, triangle ABC, and you can do that easy. We've gone over that. Today we're learning how to do it when you have two different rules put together. So here's the key. you have to do, you have your set of rules, you're always going to do the second one first. You have to remember that. So you want to write your little self a note to do the rule that is up here second first. And then the rule that appears first, you're actually going to do that one second. I know. Why is math so twisted? I know. Easy way to remember this. Easy way to remember this. Think about it. In algebra, when we learn PEMDAS, we learn that you do what first? What's inside of your parentheses, right? So 9 times out of 10, you're going to see these written like this, right? And how do you know to do this first? Because guess what? It's inside of your parentheses. So if you're related to that, you will never forget that. Always do what's in the parentheses first. All right, moving on. Not changing the slide. Okay. Another thing I want to point out. This is not commutative. What does that word mean? Anybody remember your properties? Commutative. Homework class the person that can tell me what commutative means. Yes.
Commutative means like you can, like do it like, you can do like 5 plus 6 or 6 plus 5.
Exactly. So commutative property of addition, commutative property of multiplication says something like this. If you have 5 plus 6, that equals what? 11. 6 plus 5 is also equal to what? 11. That is not the case with this. You can't switch these around. If you do, you will get your answer wrong. So it's very, very important that you know what to do first and what to do second. All right, I'll give you about 15 seconds to go ahead and finish wrapping up, writing this down, and we're moving on. Moving on. I swear I eat markers and I eat erasers. I don't know how that's good for my digestive system. It's not, but I can't ever find them. I walk around